One thing I really liked about our first questions that we did in section 1.5 with the volume and giving you that piece of paper where you cut out the corners and tried to make the maximum volume, I feel like that is a realistic situation which companies would want to figure out what's the maximum that they could make a cardboard box, or these ideas of making things a maximum using the materials you have seems very realistic and kind of practical. We are now going into what I would call a very unrealistic problem, which has only been made so you can do math. There is no situation in life where I feel this will actually happen. Okay, so we have Clara and 3 friends all born on the same day. Nice coincidence. I mean, that could happen. But Leslie's 5 years younger than Clara, Mike is 2 years younger than Clara, Thomas is 3 years older, and yes, that's all of them. Now, this is the next statement that really makes me smile, because the product of their ages was 61,136 greater than the sum of their ages. So in real life, you meet your 4 friends, you don't know how old they are, but you happen to know the fact that if you multiplied their ages, it's 61,136 more than the sum of their ages. Like, this is very realistic. This is what I know, but I have no idea how old you are. And if this was a situation that perhaps you did know that, chances are you would just ask Claire, how old are you? And then get the answer quite easily. Okay? But this is a question that's designed just to do math and have no realistic kind of application to it, other than you're going to get better at your math skills. So one of the things, though, that this question is going to improve for getting ready and developing your math skills is you have to choose how you're going to set this up. And you have to decide what's going to be a variable and how to compare everything else to that variable. Now, in this situation, everybody's being compared to Clara. So it makes sense to make Clara's age X. Because if we know Clara is X years old, we can then go, okay, Leslie's 5 years younger, so she'll be X minus 5. And Mike, 2 years younger, he'll be X minus 2. And finally, Thomas is 3 years older. He'll be X plus 3. And next, we're going to use that obscure sentence to create an equation. And I like to start to create these equations just with words. We're making an equation with product and sum, and the product is 61,136 greater than the sum. So if I just start by thinking, okay, my product has to equal sum, and I need to put that 61,136 on one of these sides to make them equal. So I sort of have to think, well, which one's bigger? The product is bigger because it's greater than the sum. So in order to make them equal, does it make sense that I would add the 61,136 to that side? Now that I said I'd write it out with words. I really just wrote it out with letters because I used abbreviations for product and sum. But now we can take this idea and write it with algebra. What does a product mean? It would mean we'd multiply all of their ages together. So that would be x times x minus 5 times x minus 2 times x plus 3 equals, and what does the sum mean? We'd add up all their ages. Well, I'm going to just do a quick mental math when adding up these. So like terms, all my x's added up, that will be 4x, and negative 5, negative 2 plus 3 will be minus 4, and I still have the 61,136 on this side. And once again, for this type of question, we're going to use our graphing calculators to solve it. We could, quite painstakingly, do it algebraically, but for the 2 days that we're going to save by using our calculator, I think it's going to be worth it. So what we're going to do to start is we are going to take our equation. I'm going to show you two methods to do this. Method number one, we're going to take the left side and put it into y1. We're going to take the right side and put it into y2. So what does that look like? So in y1, I go bracket x minus 5, x minus 2, x plus 3. And in y2, I'm going to just combine those like terms, so it's just going to be 4x plus 61,132. Now, most likely, your calculator's window is going to be set on a standard window. It's 36, but I combined it with the minus 4 to get the 32. So most likely, your calculator is going to be set on your standard window, and this is what you're going to see. So on mine, it's color-coded, so I have a blue graph. Ooh, that looks exciting. And I have a red graph. Wait for it. It's still spinning up at the top. Oh, we have no idea where our red graph is. So if we're using this method where we're typing something into y1 and something into y2, what we need to find is where they intersect. So we need to be able to see both of our graphs. Something that we used from the other day. You can go second table just to see a table of values of your graphs. So this time, my blue graph's table of values shows up in y1. My red graph's table of values shows up in y2. Notice how big those values are in y2. I mean, if you think about what we graphed in y2, 4x plus 61,132, that's a graph, you know what it looks like. It's a straight line. A line with a slope of 4 and a y-intercept of 61,132. No wonder we didn't see it when we only looked up to 10, because the y-intercept is at 61,000. So now when I'm going to my window, I know for sure that I need to have my y max more than 61,000. So maybe I'll go 70,000. And for my x-axis, if I want to find them intersecting, here I would use a little bit of knowledge about the question. Could Clara be negative 3 years old? No. Could she be 258? Well, I guess they could make a question unrealistic like that, but when they make unrealistic problems, they try to at least have realistic answers. So I'm going to guess their ages are going to be somewhere between 0 and, 100 for what could be reasonable. So I'm going to change my y max here to 100. Now, we're not guaranteed now that we're going to see if our graphs intersect, but they might. So when I hit graph now, there's my blue graph. Does my red graph should show up. Wait for it. Oh, there. Yes. And they intersect. So where they intersect is going to be our solution. So I'll go second, calculate. Now I'm trying to find number 5, intersect. It's on my blue curve, push enter. It goes to my red curve, push enter. It asks me to guess, push enter. And we get that x is 17. So if we want to put their ages, we got 17, 12, 15, and 20. So method 1, putting them into y1 and y2 and finding where they intersect will work. But you have to know how to work with your window. Some other things that are sometimes useful, not always useful, with your window. So let's say we have a standard window. This is how it started. Okay? And so now I've set up my standard window. We already know this doesn't match up. If you hit the on button while it's graphing, it will stop the graph, which is sometimes good, especially if it's graphing really slow. Okay, what's the slowest a graph has ever taken for you to finish? 3 minutes. Okay. I put in a calculation into my calculator once, and I let it run, and I put a timer beside it, and at 45 minutes, it wasn't half done graphing. That's how complicated the equation I gave the calculator. You know how fast they calculate things? And if it took it 45 minutes, I was making it hurt. Okay. Yeah, I don't know, it just never happened. Okay, so sometimes this works if you go down to zoom 0, zoom fit. Sometimes zoom fit will work out and show both of your graphs, and you'll see where they intersect. We'll see if that's the case this time. This is the zoom fit. We can at least see both graphs, but the blue and the red haven't intersected yet. So you would still need to go to your window and work with it. But at least when you go to your window, you would have a sense, oh, I needed to go up to 61,172 just to barely see red. And I know I need to go further to the right, so maybe I go to 20 and maybe I change this to 62. Is that enough to see them intersect? Yes. And then you'd find where they intersected, it would be 17, just like before. Method number two says move everything over to one side. We're not going to multiply it out. So I would subtract 4x, and since this is plus 6132, I would subtract 6132. If I move everything over to one side and make it equal to 0, when I graph it, what I'm looking for is the x-intercept. Because whatever makes this equal to 0 will show up as the x-intercept of that graph. So I can go back to my calculator. This is method 2. So now we're only graphing one graph, so I'll erase this. And at the end of this function, I'll go minus 4x minus 61132. So again, when you have your standard window, in this case, you're getting all excited to see your graph, you wait for it, and nothing shows up. Okay? But the nice thing about finding an x-intercept is when we go to our window, we don't have to worry about changing your y values because you want to see your x-axis. So as long as you can see your x-axis, you have a possibility of a solution. So if I go from 0, well, we know it's 17. So we should be able to see it if I go from 0 to 30. If I hit graph, we should get an x-intercept. Waiting, hoping, waiting. There it comes. And we've got an x-intercept. So if we want to find that x-intercept, second, calculate. Number 2 is a 0, is your x-intercepts. Push enter. And now the hard part, though, is you need to go to the left of it and to the right of it. And you don't see a cursor anywhere. So in this case in particular, I like to just type in numbers. I went from 0 to 30. It's roughly right in the middle. So I'm pretty sure that 10 is to the left of it. So I put in 10, push enter. Yes, I'm to the left of it. And I need to pick a value that I think is going to be the right of it. If you really are like unsure of yourself, you went up to 30, you could say, I'm pretty sure 29 is to the right of it. Yes. And as long as that x-intercept is between those two, it'll find it to be 17 again. 17 again? I haven't seen that one.
Not good.
Not good? Okay. Phew, saved an hour and a half of my life. So there we go, 2 different ways we can use our calculator. Now, if you didn't use your calculator, you would have had to, algebraically, multiply this all out. If you would have multiplied it all out, your number at the end would be the 61,132. What are the factors of 61,132? Well, you would start with 1. 1 doesn't work. You would then do -1. Doesn't work. 2 doesn't work. -2 doesn't work. Then you'd be like, well, what's the next factor that works? Is 3 a factor? No. Is 4 a factor? Whew. Yes, 4 is a factor. You try 4, it doesn't work. Eventually, you'd have to try 17 and -17, and they would work, and then you could use synthetic division and go from there. That's where I said the graphing calculator would save you about 2 days. Because this would definitely be a calculator question. And with the calculator question, you might ask, well, what do I need to show for work? You have to show your setup of your equation, and then you have to indicate to me if you use this technique, say I put this into y1 and I found my x-intercept from my calculator. If you use this technique, you say I put this into y1, y2, I found the intersection on my calculator. And then write out your answers. Questions you can do for practice that are also wonderfully non-realistic. Seven and 8.